Hey guys, it's Michael. Welcome back to SHENZHEN I. So if you watched the last video, you know that I claimed total and absolute failure on the infrared sensor test that we were working on, but I've spent some time doing that one and also working on another one, and I think I've got them working, but the question is, can they be improved? And the answer to that is yes. If you look at this passive infrared sensor here, here's where my bests are falling, and it's because I'm using far too large processors. Let's take a look at it and see what I've done here. You can see I've used two of the MC6000s here, and it's just because I have so many lines of code, and it's a ridiculous amount of code. But I mean, I tried lots and lots and lots of stuff. One thing that I learned, though, is that you can actually do nested conditionals. So, for instance, we could test that P0 is equal to X0, and then we could do another test right here. Now, I don't know then what happens with, we can test a false or a positive out of that, but I'm not sure really what happens if we wanted to go back and then have a negative consequence for this conditional. I don't think you can do that. It doesn't seem like it would be able to figure that out. So anyway, let's look at how I structured this, and I'm going to work to try to improve this code and get it down to maybe a couple of MC4000s rather than this guy. So what we've got here is our sensor signal. If you remember, this is a passive infrared signal. It inputs a value of 0 to 100 or something like that, and we only care when it's above 20. But we only care if it's above 20 if the time is between this on time and this off time. And this is a user set thing, which actually varies over the course of our verification. So these guys are inputting their times on the X buses, and then we're getting a real-time signal from this clock here, which is a value from 0 to 100, I think, which equates to an actual real-world time. And so only if it's within these ranges do we actually want to turn on this alarm over here. So let's look at the simplest module. We're testing that the signal coming in on P0 here is greater than 19. And what it wants to say is that alarm should be turned on whenever the sensor reads at or above 20 between the specified on and off times. Well, we don't have a greater than or equals, so fortunately we've just got one value to concern ourselves with, so I've said if it's greater than the number below it. So in other words, if it's 20 or higher. If it is, we'll move 100 to the X1 bus, and if it's not, we'll move 0 to the X1 bus, and then we sleep. So how do we handle that over here? Well, this X bus thing, you have to read and write at basically the same time. The data gets put on the bus, and then you can't do anything else until you take it off the bus. And if you read it too early, you're not going to get anything. So I've put in a no operation command here, and then I'm moving the contents of that bus to the accumulator. And then I've got a couple of other no-ops here to wait for this thing up here to finish its processing before we then check P0 and see what's on there. And so we're checking to see whether P0 is 0 or not. If it is 0, I'm sorry, we're checking if it's greater than 0. So if it is greater than 0, then we're going to move the accumulator, the value that we got from over here, onto P1. If it, shouldn't we be moving 100 to P1? Maybe. I don't know. We're going to have to check this out. And if it's not, we're going to move 0 to P1, and then we're going to sleep for 1. So we're going to ignore this guy for now. Let's just make sure this works. Does it work? Okay. It seems like it's working. I got this to work, except for in one little case over here. And these values, notice that they're changing, right? So it changes as you go along. Is it going to work? Okay, it worked. So we'll go back to continue editing here. I'm actually not sure why it's working, to be honest with you, because we're moving 100 to X1. So the value on X0 is 100. That's what we're putting in the accumulator if there's a signal. So that's why. All right, so let's look at this time checker thing here. I tried about a million different ways to do this, and the best way I could think of to do it was using two states, an off state and an on state. So when we start out, we're going to be in the off state, and that's an easy one because we know that the input here is 0. Well, I should say not that it's 0, but that state is 0. The on state is 0. That's a bad assumption. It's not a good way to go, but it's how we can go because we know what the test is requesting here. So we're testing whether P0, the signal from the clock, is equal to X0, which is our on time. If it is equal to our on time, in other words, if we hit that on time, then we're going to jump to the on state. Otherwise, we're going to move 0 to P1. So we're going to tell this guy that we're not in the right time zone, and then we're going to sleep, and then we're going to jump back to off again. And so we're going to continuously be testing whether P0 is equal to X0. And once it is, and we're going to jump to the on state and start working there. So once we're in the on state, we're going to test that P0 is equal to this guy here on X3, which is our off time. If it is equal to that, then we've gone to the point where we want to say, okay, now we're going to be off, switching to off. So if it is, okay, let me go back. If it's not equal to that, then we're on. So we're going to move 1 to P1. And then we're going to sleep for 1, and we're going to jump back to on. So we're going to keep executing this loop. If it is equal to that, then we're going to move 0 to P1, and then we're going to jump to the off state, because now we've turned ourselves off. So basically, we're just swapping back and forth between on and off states, waiting for the time to be equal to these things. Once it's equal to this guy, we switch to on. Once it's equal to this guy, we switch to off. You can't test, because this thing wraps, right? You can't test greater than, because I can't say, hey, is the time greater than or equal to 93, because between 0 and 20 is also a valid on time, right? And you can't test that we should switch off by saying greater than this value, because this is greater than this value and it is within our valid range of on time. So we have to kind of do something like this. This is a whole bunch of executions of instructions though, and we need a more expensive part to hold them all. And then the same thing with this. 1, 2, 3, 4, 5, 6, 7, 8. This would actually fit on an MC4000, so we could reduce our part cost that way. But still, I feel like this is too much going on. There's got to be some way to bum this code down, and I want to try that. But in any case, we got it working, and I'm just going to go and be happy about that for now. So the other one that we got the other day was the virtual reality buzzer. And so David or Daiwei Solomon here says, let's see, apologies for the personal side, but I met this wonderful girl named Xiao Mei, and well, to make a long story short, she's set to move in with me next month. There's just one small issue, and it's something I thought maybe we could create a product to help with. See, when I'm doing my VR sessions, I'm going to put that in quotes, it's easy for someone to sneak up on me because I can't see or hear them. Awkward, to say the least. Well, it depends what you're doing in the VR session there, Daiwei. This inspired me to think of a product, a simple vibrating buzzer that attaches to a VR headset that can be felt even during the most intense sequences. Connecting that to a radio controller, I could place the button outside of my study, and Xiao Mei could buzz me when she needs me with no chance of me being caught by surprise. What do you think? I'm sure many other VR enthusiasts might find themselves in a similar predicament, and this is a solution inexpensive enough to be an impulse buy. Yeah, great. Okay. So, Joe says, congrats, David, and JS says, here's a radio chip, and he's saying that the X-Bus normally causes the controller to block. Remember we were talking about you need a reader and a writer, but that's not the case with this radio chip we're going to be using. Because it uses a non-blocking buffer. So when it's not active, it's going to return a value of negative 999. Let's take a look at the solution I came up with, again, on the upper edge of power and production costs. So not optimized whatsoever. But here's our DX, oh no, not DX300. What is this guy? I don't know what this chip is called. It's in the data sheets, but I forget. But we've got two X buses here. We've got a receive and a transmit. We're not using the transmit. We're just using the receive, which is theoretically connected to the button that Xiaomei presses when she wants Daiwei to zip up his pants or whatever. So we got a non-blocking X bus input connected to the radio receiver. The buzzer is connected to a simple output connected to an electromechanical buzzer. And when a data packet is received over the radio, read it and execute the corresponding command in the following table. 0 is power off, turn off the buzzer. 1 is power on, turn on the buzzer. So if we look here, we can see here's our radio input. So we've got negative 999 whenever we're not getting signal. And we've got 1s and 0s when we're turning on or turning off, when the buzzer is pressed or not. And during the time that the buzzer is pressed is pressed, we're going to be sending a square waveform. Every time step we're going to go up and then we're going to go back down, etc. So that's what we want to have happen. Again, expansive code here that I've written, which is absolutely non-optimized, but hopefully I'll be able to do a better job of it. First off, reading from the bus seems to take the data off of the bus. So as opposed to being able to check X0 multiple times, I'm having to, I think, put it on the accumulator where we can then check it multiple times. So I'm moving the contents of the receive bus onto the accumulator, and then I'm testing whether it's negative 999. If it is, then we're not going to do anything. So we make no changes whenever the value is negative 999. So I jump to the end down here where we're moving what's on the DAT register to P0. Now it starts out at 0, so that's fine. Again, assuming an initial state, which is probably not a good way to design stuff, but that's okay because we always know that this is all we have to pass here. We don't care about field trials. And then we're sleeping. So if we haven't done that, if the accumulator is not negative 999, we're going to make another test here. We're going to test whether it's equal to 0. In other words, have we been told, okay, the buzzer is off now? And if it is, then we're going to jump to this off label down here, where we're going to move 0 to the DAT register, and then we're going to move that to the P0 bus, and we're going to sleep for 1. And then if none of that has happened at all, then we're going to move 1 to DAT, jump to the end. We're skipping this off. Jump to the end, move the DAT to the P0 output, and sleeping for 1. So we've handled the 3 conditions. If it is negative 999, we don't do anything. If it's 0, then we move 0 onto the bus. If it's 1, then we move 1 onto the bus. So I should say, if it is negative 999, we move 0. We move whatever is existing in the data register to the bus. So it's just going to stay in whatever state it was in. So this is a state switch. It's always either 1 or 0. It starts out at 0, and when we get the first button push, it becomes 1. When we get the button off, it becomes 0 again, etc. But I've had to use, again, another MC6000 here and put in a whole bunch of no-op operators, because we have, if you count them, through the longest sequence of events here, we've got 1 right here. We're doing a test right here. We might get this conditional here, so that's 3. If we jump to the end, we have this guy, 4. So that's 4 steps before we even put anything on the bus. If we follow another path, we got 1, we got 2. If it fails, we got 3. If that passes, if it is the case, then we got 4. And then we've got 5. And then 6. So we have 6 operations that take place before we put any data on this bus to be read by this guy. If we put it on the bus after this guy reads, then we're a step behind down here, so that's not working. Same thing, I think that's got all of us. I think that might be the longest sequence of events, because otherwise we got 1, 2, 3, 4 before we put data on the bus if it's on. So 6 is the longest sequence. So I've got 6 no-op operators here. We're going to check and see whether it's 0. If it is 0, then we're going to move 0 to P1 to the buzzer output, and then we're going to put 0 in the accumulator and then we're going to jump to the end, and the end is just a sleep function, in which case we'll go back. Now the reason we're putting 0 in the accumulator is because we want it to start out at 0, because if the value on P0 is actually a 1 and we pass through here, we get to not, and what not does is flips the accumulator from 0 to 100. So as soon as we get this 1 here, we're going to flip the accumulator from 0 to 100, right? And then the next time through, the value on P0 is going to be 1 again, so we're going to not it again and flip it to 0. And then same thing, if it's still on next time, we're going to not it again, and it's going to go back to 1, etc. So let's see this guy working. I think it works. Yeah, looks like it is going to make it. So I think my problem grokking this, apart from my brain kind of being half strength the last week or so, is one of timing, is of coordinating the timing between these simultaneously executing devices, right? So the ideal thing here is to make stuff, get stuff on the bus to the next device as quickly as possible, because otherwise I'm wasting 6 operations here, basically doing nothing. I don't know a way to avoid that right now. I'm sure there's some clever way, and I'm sure people that, well, actually, people that program in machine language are used to sequential operation as well, except maybe hardware guys. Maybe hardware guys are fully familiar with how this stuff works. I'm new to it, so this is my best guess right now. I think we can do better, but I'm going to keep working on these, and we'll see. Okay, so those are the 2 problems that we had. We also have new nifty stuff. First of all, from Carl Teskey here, we got a prototyping new ideas thread. Sometimes a decent idea falls out when you're faffing about with chips and code and the like, and I've set up an empty prototype board for us to experiment. On you go then, chips. Gia says we can test some different parts too, such as custom LCD panels, and we'll add other parts as we receive them. And Carl says, custom LCDs, are you serious? That's brilliant. We could make retro-style handheld games. Let's take turns designing one, and Gia tells him, hey, if you're done with your work, I've got more for you to do. So there's that. We'll take a look at that in a sec. And then into device 2A27 from Poseidon 799, outreach app control.poseidon, unknown optimization device. A decentralized autonomous corporation has determined that thorium mining operations can be optimized by as much as 2.7% by creating a device with certain specifications. Those specifications are included in this communique. Please create 50 of these devices, ship us to us. Payment will be included or will be forwarded upon verification. Joe wants to know what this is about, and Wu Li helpfully explains that a decentralized autonomous corporation is a company run without human involvement. It has money and investors, but it makes decisions for itself on what to do with that money using information from multiple lower-level monitoring and analysis programs. Apparently, they're not much used anymore and stuff. So anyway, this creature has sent us specifications for a device. And from Joe, a color-changing vape pen. Joe's got a deal from Cool Dad, who apparently is a musician, getting ready for his global tour and getting ready to sell some colored vape pens. And we have to control some LEDs to get the shade we want. Little tip for you. See the little triangle at the beginning of the Express data packet? That's when all of those values in that packet are coming in. It's not like it's 1 per time unit. Okay? Yeah, so those are the ones. Let's take a look at this device 2A27 real quick. And I'm going to work on these offline because there's just no chance of me actually being able to solve them online. So here we have actually just 2 simple inputs, X and Y. Inputs connected to an unknown device, presumably some type of position sensor. Power is a simple output connected to an unknown device, presumably some type of motor or high-power switch. We're supposed to map the X and Y coordinates to the corresponding power value as specified in Poseidon 779's geometric specifications, which can be found in the supplemental data section of the manual. And let me grab that page and I'll show it to you. Well, I've just realized that my webcam is off, so I can't actually show it to you, but it says Thorium Mining Unit Actuator Control Subsystem 27A27 Geometric Specifications. And what we've got here is a little square with X and Y values and some internal mapping of the resulting values. So for instance, while X is less than 20 and Y is anything, then the value is 30. And there's some other ones here. So like when X is between 20 and 60, it's usually 0 except when Y is between 40 and 80. And then when X is above, greater than or equal to 60, it's usually 30 except when Y is between 40 and 80. So that's going to take a bit of work to just sort of manually make all that map out. And again, I'm going to do this off camera. I'm not even going to try it on camera. And we'll see where we get to. But I will come back and try to explain how the circuit went. And I'll also save multiple versions. Like if I have trouble or find different ways to do it or whatever, I'll come back and we'll walk through them. Not going to happen on camera. Sorry, guys. I'm not that smart, to be honest with you. Let's look at this vape pen thing, though, real quick. So I haven't even looked at this yet. So we've got an input signal here, radio RX, a non-blocking X bus input connected to a radio receiver. LED R, G, and B are simple outputs connected to an ultra-bright RGB tricolor LED from top to bottom. So RGB over here, simple outputs, not X bus. When a data packet is received over the radio, pulse the LED as specified. So we're going to get R, G, and B intensity and pulse duration. If a data packet is received while a pulse is in progress, interrupt that pulse. So let's look at this. Oh my goodness. Yeah, so we're getting a data packet here. And then here's our output. So we got 0, 50 on G, and 100 on this, and then it's just like a 999. It's just like a non-terminating pulse, but we're going to swap it over as soon as we get this new packet here because we're interrupting it. And then we get a guy here that tells us for 4 we're going to do this this setup, 150, 0. So yeah, that's going to be some more work probably. We'll take a look at that one next time as well, although that one looks a little easier to solve. And then finally, let's take a quick look at this prototyping board, which is pretty cool. So we've got the MC4000, we've got the MC4000X as well now, which doesn't have simple inputs. It has 4 different X buses, so that's a new part that we have access to. With the MC6000, we have this DX300, which is, I think, yeah, this breaks down X-bus inputs into 3 simple outputs, which is pretty cool. So we can plug an X-bus input into here, and I think we give it a 3-digit binary number, so like 100 would give us 100, 0, 0. 001 would give us 00, 100, like that. So that's a pretty cool way to sort of multiplex information. We got this guy here, which is a simple on-off button, which is pretty cool. So let's see, can we, I'm gonna jump on down. We've got a few more things than I had before. Actually, let's just grab one of those guys. That's pretty cool. Is that an X-bus input or what is that? Let's just connect this up and move to simulate and try this out. Yeah, so this button here is a simple output. It just provides an on signal. So we could, for instance, I've got to stop simulating here. Yeah, so we could, for instance, pop that down there too. Oh, press simulate. Yeah, so simple on-off. That's pretty cool. Reset. I wonder if there's a keyboard shortcut for those things. So those are pretty cool. We got a couple of different LCDs. I don't know if this is blue or what. Red, green, blue, amber, and white, I guess, probably. We have like a gamepad controller here, which is pretty cool. So we got WASD keys actually interact with the thing when you're working. They yield a signal of 1, 2, 3, 4. And let me go on down to this guy. This guy's a simple numeric display. So I think if we output to here and we simulate, when I press W, it doesn't do anything. Why not? Maybe this is not the panel I thought it was. I thought it was. Hang on. Let's reset that. Let's pull that out of there. Did I not hook it up? Okay, we got two different kinds of LCD panels here. Let's get rid of that. Let's pull this over. This panel's pretty cool. It shows a picture, a grayscale image, if you have it selected here. Otherwise, if you click here, you get a matrix. So when you input a value to, actually, here, we could, you can't do that. You can't have these things stacked, so you have to kind of push them around a little bit. Tower of Hanoi with them. If we press simulate here, hopefully this is going to work for me. If I press W, nothing is working with this thing. Why is this guy not working? I don't know. You know what? I had this thing working the other day, so I'm not sure why it's not working now. Get rid of that guy. Bring this guy back, and let's try our button again. If I can get to it. Here we go. So we put that in there. Pin type mismatch, because that wants an XBus input. Okay, that's not going to work. I'm trying to find something that will give us like a value. Will this do it? This thing here I thought displayed numbers, simple numbers, but it doesn't seem to be doing that. That's very odd. I can see the 100 or 188 that it could display, actually maybe more than that, a minus as well. But it doesn't seem to be working for me now. I thought I had done that before. But anyway, we got our bridge, we got this big LCD panel, we got a little LCD panel, we got this guy, which I'm not real sure what this thing is, to be honest about it. I'd have to look in the data sheets to see. Here's our tricolor LED, and we got our timer input thingy, or actually any value input thingy. Got this guy, which I haven't seen. This is a simple on-off kind of switch too. If we simulate that, yeah, so it's just a single pole, single throw switch. Actually, maybe single pole double throw technically, because I believe that if we hook this guy up, that we get, oh no, okay, yeah, single pole double throw. I think that's what how that works. I get confused on those sometimes. So we turn it here, the red goes, we turn it here, green goes. That's pretty cool. All right. What else do we have? Is there anything else that's unlocked in here that's interesting? I don't think so. I think that's it. I gotta tell you though, I'm a little confused on why these LCD screens aren't working for me. I swear that I had them working. That when pressing these buttons, it would show up on this screen with a number. But it doesn't seem to be doing that now. No, nothing's doing anything. Very strange. Do I need to have, I'm gonna have to end this episode real shortly, sorry, I know it's going on a bit. Let's see if we need to have a microcontroller in here. So we take that, and say move x0 to x1, sleep 1. Is that going to work? Okay, well there was no data flowing before, so maybe this thing needs a controller. So if I do W, yep, there we go. It's a 1, a 3 for A, a 2 for S, a 4 for D. For some reason it's showing us a negative symbol, so I don't know if that's part of this or what. So enter gives us an 8, J5, K6, 7, 1. And if we were to put, say, this guy instead on here and change this to P0, so we're moving P0 to X1 and sleeping. It's showing 0, but when I click the button, it's showing 100. There we go. Okay, that's working much better. And finally, let me then do one more thing. Sorry, I know it's going on a bit, but let me grab this guy, move it over just a little bit so we make sure we have enough room. Get rid of that. Oh, yeah, pin type mismatch. It doesn't like that because this is an X bus. Right. So we're going to move X0 again to X1, and we're going to take this big LCD display, hook it up, switch it over to matrix mode, and try running it. Now let's see what happens. Yeah, see, when we press A, we get 3. So this is 1, 2, and 3. If we press W, this top one up here should be lighting up. Yeah, that's right. And D should give us 4, and S should give us 2. Enter should give us 8. J, K, 7. So you can create, some images here, although I don't know how you get enough instructions to really do much of anything with it, but I'm sure it's quite possible. I have seen people do little animations and stuff. I've seen images of it anyway. I haven't actually seen them working or seen the code behind it, but just doing a Google image search, you can see some pretty complicated things that people have come up with. And so that's going to be super fun to play with. If I come up with anything interesting, I will show you guys. But until then, I will see you later. Bye.